Look at a flat mirror. Flat mirrors form virtual images, so we actually have, I've pre-drawn this, so we have the object here, which is a person, and the image of the person is here. The image of the person for a flat mirror is into the mirror an equal distance that the person is from the mirror. So if you call this the midpoint, this is the distance to the object that we call DO. This is the distance to the image, and for a flat mirror, DO is equal to DI. Now let's use the law of reflection in order to analyze what's actually happening to put a reflection, an image, in a flat mirror. Let's start with looking at the eye there, and let's say that an incident beam of light comes in, strikes the person's foot, and reflects off of the mirror. We're going to get the midpoint between the person's eye and the person's foot, because those are the two reference points. And the law of reflection states that theta 1 is equal to theta 2, where theta 1 and 2 are measured from the normal, which is perpendicular to the surface of the mirror. We're going to draw the incident beam of light. The incident beam of light is the beam of light that is coming off of the person's foot, going straight to the mirror, and that is measured at an angle of theta 1, and then it reflects off of the mirror. This is the ray of incidence, this is the ray of reflection, and theta 1 is equal to theta 2. So the reflected angle is equal to the incident angle, measured from the normal. And the actual image, if you take the angle of incidence, or the ray of incidence, and draw a dotted line back into the mirror, the person will see, the eye will be up there, and then if you take the reflected ray and draw a dotted line back, that would be how the person would see their feet. I'm going to erase the top line and keep the bottom dotted line, because we're going to need another line in there in just a second. Now let's see that the person is trying to see the top of their head. Now that means that you're going to measure from the top of the head to the eye, and the midpoint on the mirror would be there. So you have the incident ray and then the reflected ray. And measuring from the reflected ray, you ray trace the dotted line back, so you get the entire image of the person. Now, if you imagine an infinite number of rays coming off of the person and striking the mirror and reflecting back at an angle theta, in between the top of the head and the bottom of the feet, the image would show up. And that works by the law of reflection. Now, this image is a virtual image. There's a difference between virtual images and real images. A virtual image appears to be inside of the mirror. A real image would appear on a note card or a piece of paper or some surface in the regular environment. So it would reflect, the image would reflect off of something. So there's a difference between real images and virtual images. For a virtual image, it appears to be inside of the mirror itself. Now this image is also going to be reversed. So you would read, if you held up a sign, you would read the words backwards. So we have, the object will appear to be into the mirror, or rather the image will appear to be into the mirror, an equal distance that the object is from the mirror. It's a virtual image, and it's reversed. And those are the basic ideas behind flat mirrors.